Hello. So now let's talk about the principle of strong mathematical induction. So strong mathematical induction is very similar to regular mathematical induction, and in fact, they're mathematically equivalent, but you don't really need to know that right now. All you really need to know is that in practice, they look a little different. So let's talk about what's going on with it. So similar to regular mathematical induction, we're going to have a base case. So we're going to have a base case, and then similarly, usually p sub 0 or p sub 1. And this we might actually have to do a couple of base cases, and we'll do an example of that. And we'll talk about why. And then the inductive hypothesis is not only assuming that, one predicate is true, or the predicate is true for like some k. We're going to suppose instead that the predicate is true for all values between the base case and some other number k that's greater than or equal to the base case. So we need all of these are true, not just one. And then the induction step is supposing that all of these are true, then we get that the k plus first term is true. And so the idea is very similar to induction. And so just in practice, it looks a little different. So we're going to say that, the statement is true for some base case or a couple of different base cases. And then the inductive hypothesis and induction step are that given that, the statement is true for like the base case up through some number k, then all of them imply that, all of them together imply that the statement is true for the k plus first term. And then if those two statements are satisfied, so if we have some base case and we have that, all of these together true implies that the k plus first term is true, then it's true for all natural numbers n, or all natural numbers greater than or equal to the base case.